Good morning everyone. As part of learning generative AI, we will be learning the concepts of attention mechanism, where it is used, what are the advantages of using that, and what could be the drawbacks if we don't use attention mechanism. Let us have a quick introduction of what exactly is attention mechanism. The attention mechanism is a technique which is used in machine learning. To be specific, it is used in deep learning models, which will try to improve the performance of a model or accuracy of a model by focusing on which input parameters are important or relevant for the output to be produced. See, whenever we take the data set, we might have n number of input parameters. This attention mechanism will help us to identify which input parameters are relevant to the task which we are performing or the model is performing, and which input parameters can be neglected without losing the relevancy to the output that is to be generated. Let us quickly look at what exactly is the purpose of attention mechanism. Whenever we are trying to work with tasks like language translation, text generation, it is identified that not all the input parameters or the entire input sequence is equally important. So some parts of the input sequence are highly important. Some parts, even though you are not using them, you can understand from the context, right? Say for example, I'm saying I am teaching generative AI. This is the sentence, right? Say for example, when I want to stress upon what is the major stress in this sentence, or what is major importance in what is important in this sentence? Teaching generative AI. So I'm teaching a specific subject, generative AI, which is important to the context. In such case, what I can do is I can skip some of the words like am. So the context can be understood as I'm teaching generative AI. Whether the verb is correct or not, whether grammatically it is correct or not, just keep it aside for a while. Teaching generative AI, and who is teaching? I. So these input sequences are important compared to am, right? So you are trying to attach the relevancy and importance to the input parameters using the concept attention mechanism. So whenever we are trying to work with attention mechanism, what is the working principle? How does it work? Whenever we are trying to do any kind of training for a model, we try to take the data set, attach a weight to every input parameter that is given in the data set, or we also call that weight as attention weight. This attention weight is nothing but how relevant is that input parameter for doing the specific task. Then, after assigning weights to each and every input parameter, the model computes weighted sum of all these input features based on the attention weights, and it will try to identify from the weighted sum which are the significant parts of the input. So how many types of attention mechanisms are listed here? There are basically two types of attention mechanisms: self-attention mechanism and bow-down and long attention mechanism. Under self-attention mechanism, this is specifically used in transformer and all, which will try to model the weights and the model. What it will do is it will try to take the weights which are related to different parts of same input sequence. we will see in detail what exactly is self-attention mechanism, and the next two attention mechanisms are early types of attention mechanisms which are specifically used in sequence-to-sequence models. And what are the key applications of this attention mechanism? We specifically use it under natural language processing with tasks like machine translation, text summarization, and sentiment analysis, etc. Under computer vision, we will be trying to use it for image captioning. We attach captions to various images, like similarly tagging, image segmentation, etc. And transformers, what exactly are transformers? As I told, attention mechanism is mostly used in transformers. The self-attention mechanism is used in transformers. Modern deep learning techniques, they are trying to work with models, and these models are called as the transformers, which work with the self-attention principle, wherein they are more efficient for handling long sequences of inputs compared to the traditional RNN models. Examples for such transformers are GPTs, BERT, etc. These are the models wherein self-attention mechanism will be used. So when you are talking about attention mechanism, it can be summarized as it enables all the machine learning models to improve the accuracy and performance. How it is doing this? By allowing the model to focus on the most important input parameters than considering all the input parameters that are given. How do we assign weights to improve the relevancy of an input parameter? We are assigning weights to the input parameters during the attention mechanism, which will help us to focus on the relevancy of an input parameter for the specific task. How do we do that, and how does it help to improve the relevancy? First, we do something called as score calculation. For every input parameter, we assign some weight, and we will try to calculate its relevancy score, right? So how do we compute? Using certain measures like dot product, scaled dot product, which are listed out here. We try to use some of the calculation mechanisms, and we try to calculate the relevancy score for the input parameter. After calculating the relevancy score, we pass it to something called as softmax function, which will try to normalize the score of an input parameter into the range 0 to 1. We also call them as the probabilistic measures, and we know what is the meaning of probability score for a particular given input set. The sum of all the probabilities of all the elements will be equal to 1. So the softmax function will try to convert the relevancy scores into probabilistic measures. These probabilistic measures are called as the attention weights. For an input parameter, if the attention weight is high, the relevancy of the parameter is identified to be high. If the attention weight is low for an input parameter, you can neglect it without losing the meaning of the input parameters or meaning of the input data set. Weighted sum. After finding out the attention weights, the model then calculates the weighted sum of all the inputs, and the attention weights will tell how much relevancy each input parameter is contributing to the final output generation. Say for example, whenever you are trying to work with translation, say for example we are translating a sentence which is given in English to French and trying to predict a verb. When you are trying to predict a verb, the input keywords in the sentence which contribute to highlight the verb, like adverb, the subject, the object. These things are given higher weights compared to the words like the, a, and. Such words are given lesser relevancy score compared to the words like, as I told, the subject of the sentence, the object of the sentence, and the tokens which are trying to highlight the chances of predicting the particular verb. What is the key advantage of doing this? When you are trying to dynamically adjust the attention weights based on the task we are performing, we are trying to focus on the input parameters which are relevant for the output data prediction or output generation, and we are not literally wasting our time in working with the input parameters which are not contributing towards the output predictions. So to summarize, the attention weights are enhancing a model's capability to prioritize the inputs which can be considered, which can be neglected according to the context. Coming to the vanilla sequence-to-sequence models, these are often based on RNNs, which are widely used for tasks like machine translation, summarization, speech recognition, etc. They are still suffering with some limitations. That is how we are going for the attention mechanism. What are the limitations? Let us quickly look at. Fixed length representations. The vanilla to vanilla sequence models, they try to compress the entire input sequence into a fixed length context vector. And what would be the bottleneck in this? Some of the necessary information is lost compared to the data which is not relevant to output generations. Difficulty in handling long sequences. The RNNs generally struggle when they are trying to process long sequences compared to shorter input sequences. As the length increases, the performance tends to decrease. Vanishing gradient, when it is trying to fit the entire long sequence into a single context vector, fixed size context vector, we might forget some of the input relations and relevancies. When the model is trying to forget the relevancies and relations, LSTM and GRU are helping, but they are not completely solving the problem. And the decoder, whenever it is trying to decode the output tokens, it has only the access of the context vector generated by the encoder. It doesn't have direct access to the input parameters. This is one significant disadvantage or drawback. And these RNN based models, they work very well for sequential processing, but they are failing when we are going for parallel processing. No explicit alignment. When you are working with vanilla sequence-to-sequence models, they don't have any built-in mechanism for explicitly aligning all the input tokens to their respective output tokens, because of which we are unable to identify which input word corresponds to which output word. Poor handling of rare or unseen words. It works with a fixed vocabulary set, and if at all any word is falling out of this vocabulary set, it marks it as UNK, stands for unknown token, because of which also we might lose some important information. Context vector overload. What happens is different parts of the input sequence might have some relevancy information. When we are trying to fit the entire data into one fixed size context vector, we might have the chances of overloading or suboptimal decoding of the context vector. What are the solutions? Use the attention mechanism, which can process the input sequence dynamically, and we are not fixing to a fixed size context vector. And the transformer models like BERT, GPT, they are trying to solve the process of handling long range sequences and the self-attention mechanism. With all these things, they are trying to process long range sequences. Thank you.